To prove that 5 to the n plus 3 is divisible by 2. So part C. First thing I like to do is call the statement Pn or Sn or something. So I'm going to let Pn be the statement 5 to the n plus 3, and they said that it is divisible by 2. So I'm going to write that 5 to the n plus 3 is equal to some 2 to the x, where x is an integer. X has to be an integer because it is divisibility, where x is an integer. All right, so let's knock out this question real quick and fast. So the first step that we know is that when you're doing proof by induction, you start with when n is equal to 1. So when n is equal to 1, what we're going to get is 5 to the 1 plus 3, and 5 to the 1 plus 3 is equal to, yes, we know it's 8, but look how I'm going to write 8. I'm going to write it as 2 times 4. So yes, and so hence P1 is true. So we can conclude P1 is true. We call the statement Pn, so P1 is true. Nice. Now that we show that P1 is true, let's know for n equal k. For n equal k, what we're going to have is 5 to the k plus 3 is equal to, let's call it 2 to the q, or 2 times q, where q is of course an integer. Where q is an integer. Nice. Good. Now, next thing is that we need to assume that n equal k is true. So we're going to assume n equal k is true. So now that we assume n equal k is true, you only need to look at the final step now, and the final step is to prove that n equal k plus 1 is true if n equal k is true. So now when n is equal to k plus 1, n equal k plus 1, what we're going to get is 5 to the k plus 1 plus 3. All right. Now, I'm going to go back to over here. We're assuming this one is true, but if I was to make 5 to the k the subject, right? If I were to make 5 to the k the subject, I would say that 5 to the k is equal to 2q minus 3. Agreed? Yes, yes. So now what we're going to do now is, instead of writing 5 to the k plus 1, I'm going to break that down as 5 times 5 to the k plus 3. That's how I'm going to break it down. But then, of course, 5 to the k is 2q minus 3. So what I'm going to get is 5 times 5 to the k, and 5 to the k, which is 2q minus 3, plus 3. Nice and easy. After you do this now, you just expand through this bracket, and what you're getting is 5 times 2q is 10q, minus 5 times 3 is 15, plus 3. And so what this works out to be is 10q minus 12. This works out to be 10q minus 12. We wanted to show that's divisible by 2. So we can go ahead and factor out 2. You factor out 2, you're going to get 5q minus 6. So hence, it works out to be, you can call all of this like a j. If you call all of this like a j, it works out to be 2j, and so hence it is divisible by 2. All right, and so hence, I can say therefore, pk plus 1 is true. pk plus 1 is true. Now, anytime you write that pk plus 1 is true, you don't finish it. You always write a conclusion when you're doing mathematical induction. So you're going to write hence, by principles of mathematical induction, by PMI, we can say that the statement Pn is true for all n an element of natural numbers. It's true for all natural numbers. Nice and easy, soft. That takes care of the induction part. All right, now we reach part D. Part D, it says, f of x is x cubed minus 9x squared plus px plus 6t.